I think we might be live, so I'm just confirming. Give me 1 second, and then we'll get started.
I did check, on the other window. It seems to be that we are live.
Yeah, I think we are live. It says live at the bottom.
Okay.
Oh, there you go. For a minute already, we've been sitting here and we were looking.
Trying to build up the anticipation, right?
Oh,
All right. Well, in that case, let's get started. Thanks, everybody, for joining. The panel today is going to be on manufacturing analytics and driving profitability, productivity, and transformation. So thank you again for joining. My name is Amy Tenanes. I am a product marketing manager at Dell. The products that I'm responsible for are the streaming data platform, which helps organizations to ingest, store, and analyze their streaming data, and also the data management initiatives of the company. Because at Dell, in addition to being a trusted leader in storage infrastructure, we're going beyond helping people to store their data, and we're helping people to monetize their data. We are making the power of AI accessible to organizations of all sizes, with solutions and services needed to achieve success with new and emerging use cases at the edge. So we're going to hear a lot about that today. But as we all know, there's always a lot more to be done in the industry. With the inception of edge data comes massive amounts of data that need to be secured, stored, scaled, cataloged, governed, and more. So all of this brings a host of challenges, nearly as great as the potential that the data itself holds. So today we're going to speak to these fantastic resources we have here about their own challenges with data management, data science, and advanced analytics, and what they're doing to overcome those challenges. So we'll also talk a bit about the industry in general from a macro view. Just a quick reminder and note, the panelists' commentary does not reflect the views or opinions of their respective organizations. So without further ado, I'm going to ask each of the panelists to introduce themselves. And during your introduction, if you could just say one cool thing that you're doing using data science in manufacturing today, that would be great. So let's start with Amit.
Hi, good morning. Can you hear me?
Yep.
yes.
Okay, great. So I'm the director of data science and insights at Novelis. Novelis is a aluminum rolling company, and we are based headquartered in Atlanta, but we have plants, 30 plus plants in 9 countries all over the world. So we are a global organization, and my team basically does use cases in manufacturing using machine learning and data science.
Oh, maybe he's not here. Evan.
Hey guys, can you hear me out? Okay. All right. This is Evan Kan. I'm with FedEx. I'm a senior decision scientist at FedEx. So I'm with the team. We are using advanced analytics and cutting edge technology to better optimize our operations and provide insights to our leadership. So one of the cool things we use our data to do today is trying to tackle the labor shortage problem during the pandemic. And that was a really challenging project to do, but we're trying to work around it to get our customers the best service that they deserve.
Awesome. I want to hear more about that later. Attila, your turn.
Yes. So my name is Attila Lengyel. I lead the capability analytics at Intel for the NAND business. It's a flash business unit. And one cool things we do, we plan to cut few percentage of billions of dollars investment in capex capital.
Awesome. And Jai.
Hey guys, this is Prakash here. I work at Suntory. I'm the director for planning analytics, and I've been here for about a year. Prior to that, with Reckitt for over 6 years, so a lot of CPG experience coming in there. I help to look at the supply chain as well as the production planning and all of the detailed analytics that goes into making a successful product for us. Thank you.
Okay. All right. So with that, let's just get right into our first question. According to a research study, 69% of manufacturing IT infrastructure will be deployed at the edge within the next 12 months, in the next year. So do you see a lot of this growth at the edge in your own organization? And what kind of challenges do you face in creation, collection, analysis, and storage with that edge data? Evan, do you want to start?
Yeah, sure. So we mainly use our edge computing in our new EV truck fleets and autonomous vehicle development phase. So because of the large amount of data that autonomous vehicle, like self-driving cars, so they process sensor data on board the vehicle to reduce the latency, but we can still connect them to a sender location for like over-the-air software updates. So we have a challenging in there of processing the real-time image and video data to help our drivers on board and our packages deliver safely and to our customers timely.
Awesome. Anybody else want to share how they're doing it?
I can go. And I have seen a pretty dramatic increase in that type of use cases where we are deploying the ML models on the edge. So fog and edge, that's I would say. Historically, we started with building our models and deploying those models in cloud, but as our business is changing, we are building use cases in augmenting decisions of our operators at the shop floor. And in those cases, deploying the models in the fog or on the edge is quite crucial for them to get the real-time recommendations from our models. So one of the biggest challenge that we see is the IT/OT integration in that regard. So at this point, many companies are still acting in silos for IT and OT. And for edge case deployment, we need to have a much more seamless integration between those two areas. And I think the tools and ecosystem in that area is still very nascent. So that's kind of like, I think, one obstacle I would say, or one challenge I would say in overcoming doing more use cases on the edge side. But I think the request or requirement in that area is changing quite a bit.
Yeah. It's funny, a lot of the data issues are really more cultural, data culture, data knowledge, things like that, things that really don't have anything to do with tech. So I was hearing those challenges.
If I may, I'd like to share about Intel a little bit, because at Semiconductor we are very proud and take pride that we have been using edge compute for decades. If you look at these factories are multi-billion-dollar worth. Some of our equipments are hundreds of millions of dollars. So you can't really run these equipments without having really good edge control. We called it, earlier phases APC, Advanced Process Control. And that will do a run-to-run control or a fault detection to be able to improve our capabilities. Now, one interesting things that challenges is that we really would like to keep the false negative extremely zero, right? So you don't want to really make a bad decision, because a bad decision might cause multi-million dollars worth of within hours yield or other issues. So therefore, what's happening here is that usually with the new algorithms, right, we go more on the false positive side, right? So we rather take more false positive than false negative. Therefore, your labor requirements to keep the machines running, especially if you add these edge devices, becomes really a hurdle, because it's pushing the decision making to the technicians. So I think there is a balance, what models you use and how you're using it. I think the biggest challenge is to create these models on the shop floor that can do really good decisions and augment the technicians, not hold them back because there's so many false positives.
We hear a lot about the need for data cleanliness and the concern about how clean data is. So that's a really interesting way to do it. That sounds awesome. And did you want to also go? Jai?
Sorry. Yeah, I mean, in the industry that I am, it's been a very traditional business. It's over 200 years old, and the process that we do, Beam Suntory makes alcoholic beverages, so it is a very traditional business, and there's a traditional way of doing it. The way we would employ, or the way we're trying to look at, augmenting some of our analytics out here is in terms of micro planning, and at depending on what's happening on the shop floor, because some of the techniques that we're using today, there could be bottlenecks, and in terms of how we plan for different parts and production adherence on that. So when those are impacted, we still stick to our old plans, but with the help of more and more data that's coming in right now, right from the edge of the device, right? We're trying to see if we can make decisions which are more flexible and which do a little more micro planning rather than stagnant static plannings that's there today.
Awesome. Sounds very agile. All right, so next question, still relating to data, of course. A Forrester study says that 70% of organizations gather data faster than they can use it. And there's been a lot of changes in recent years in the way that we govern and leverage that data. In your opinion, what are some of the biggest challenges that the manufacturing industry is experiencing, and how are you trying to address those challenges today? Attila, do you want to go first?
Sure. So I think if you make that survey a few years back, I think the 70% would be even more. So I think the trend is that companies do use more and more data, and they, with the infrastructure changing and availability of the cloud infrastructure, helps companies to tap into this unused data. Now, just a simple example, I had a really small project 2 months ago, and we started to collect data. In 2 months, we collected 8 trillion data points, and just it was a small project, and they need 3 years retention. So when we look at when you definitely speak about faster, it's speed, right? So meaning that can you use the data that's streaming into you in time so that you make decisions for manufacturing. Now, I think very now in manufacturing, one of the key challenges is yield, right? So we creating these chips or products more and more complex. The parts, the steps, almost exponentially increasing in terms of 10 years ago what a chip looked like, and now what a chip looks like, and the technology is Moore's law as we follow. These chips becoming extremely complex. Because of the complex process, you're more prone to make failures and errors. So therefore, your yield is getting lower and lower. So what you need to do, if you don't do nothing, is just add more processes because of the statistics, you're going to end up with lower yield. So you have to continuously improve the yield. You need to continuously tap into your process data, understand what failures, correct, and make corrective actions. Now, this is really complex to be able to make corrective actions. So I really liked Amit's comment where we have to augment the engineers to make decisions faster, better. So that augmentation is what I think the most important for this. Not just fast use the data, but can we augment and enable the process engineers or the engineers and other planners to quickly react to problems and avoid the problems and make corrective actions.
Thank you. Jai, it sounds like you were mentioning that you're a little bit more traditional. Are you guys kind of starting a little bit slower, trying to kind of what you were saying, Attila, is kind of taking it as you go and taking little pieces? Would you look at that?
Right. I mean, so one of the big challenges we have, when we throw out a lot of analytics is that, we need to make sure that the people on the shop floor are really ready for that analytics, right? So because it's an evolving industry, and if you throw too much analytics, you're trying to take away their critical thinking from that process, which is very critical for an industry like us. And we need to be careful about how much we roll out. So even though we have a lot of information, we wouldn't be able to take full advantage of that, or take full advantage of some of the automation that might come in, because it might just fall back and say, I'm not really, this is what the machine said, right? Or this is what it's saying. So the adoption levels also, we need to be careful about that. So it's sort of a more of a planned and phased approach. We have to go slowly, more deliberately, in terms of how we approach analytics for the shop floor there, and making people understand what is being done and how it's being done and how those decisions are being made to get that more transparency rather than take the black box approach of this is what the algorithm said and this is what we're trying to do. But instead, we try to show them with use cases itself, why certain products have to be manufactured in excess in terms of inventory control, or why certain products have to fall back. So that's how we're trying to maintain our inventory balance in terms of looking at the change in demand patterns instead of talking about, a coefficient variance and then looking at all of that segmentation that we're trying to do. We're relating it back in simple terms and, trying to relate that back to the users in a more friendly way. But that said, again, to the point of, more data coming in, sometimes it's hard for us to not have that data to start with on an initiative, because it's always good to get that data, have it ready, because when you're doing your models or analysis, you need to have that historical data available for you to do that. And with the absence of that, you can't even get ahead. If you have a project that's getting kicked off, you can't do anything with it without that historical data available there. So that's one of the challenges that I have faced in terms of, rolling out new initiatives or levels of effort. Stoppages not available, not enough available data at the right granularity.
Awesome. Amit, did you want to talk a little bit more about that idea of augmentation?
Yeah, I think if you think about manufacturing operations, right, historically, the data was captured in silos. If you think about the Purdue model of manufacturing L1 to L5, right, you have the PLC SCADAs, and then you have historians, and then you have the MES systems, and then you have ERPs. Historically, a lot of those were disconnected, and people basically acted those on those each of the systems in silos. I think where AI and ML can really help is if you can connect those systems and then take decisions or help decisions to be better based on the augmentation of that data. So I feel like one area where we are seeing a lot of challenges at this point is how do we connect these systems, right? And people are using data lakes for that to bring that data. But given that data is collected in silos, that creates problems of connecting data across those multiple layers. So I think once we can, so governance basically becomes a very big portion of generating value from AI and ML use cases. Your AI and ML models are only as good as your data is, and so companies are putting dedicated efforts into the governance and data quality, and only once you do that, then you can start seeing the value from your AI ML models.
And rightfully so. That your data, like you said, is only as good as your foundation. So paying attention to that foundation makes total sense. Evan, what are you seeing at FedEx?
I can't agree more to what Amit said about connecting to different systems, because not surprisingly, from FedEx, we are collecting data from lots of systems, right? From our airplanes, from our workers, the packages in the hubs, and the packages on the delivery vehicles. So those data are collected in silo, and how do we connect them is a big challenge for us. So one of the projects we're working on is trying to is data democratization, is trying to get the right data to the right people when they are doing the analysis. And then that is not as easy as it sounds. And as we are migrating to a more hybrid cloud or a full cloud infrastructure from our own old traditional data warehouse, that's a challenge adding to a next layer, because there are data living in the cloud, data living in our data centers, and how do we connect them together, and how do we make sure the analysis coming out of them are aligned, is something we're trying to tackle today.
I can tell you just with my Amazon packages alone, I know you guys have a lot of
Just take the box back.
You can blame Amazon for that.
All right, so further to that idea of what we're doing with the data, another research study says that 57% of manufacturers are already performing AI and machine learning inferencing at the edge. So are you guys doing any AI or ML? And if so, are you seeing a lot of value come from it? I would think so. And how do you see these aspects of data science and advanced analytics impacting manufacturing and supply chain on a macro level? Let's start with Amit.
Yeah, I think that's one area where I'm seeing a lot of growth at Novelis. Like Jay, our industry is also very traditional. Aluminum rolling has been around for 250 years, right? But as with the Industry 4.0 coming at bay, it's kind of like changing how we look at our operations, our data, and data is becoming a big asset to understand different aspects about a business, whether we want to increase throughput of our operations, whether we want to reduce the energy consumption, reduce defects in our operations, machine downtime. Those are some of the use cases which are actually being considered now with the advent of AI and ML. So in many of those cases, we have to deploy the models back in the plants. And so few of the use cases where we are seeing is applying computer vision to augment decisions that operators make based on what they see. So instead of like them looking at things and perhaps sometimes under fatigue making wrong decisions, if we can provide them a better recommendation on, for example, where to cut certain things or where to weld and stuff like that, it can actually improve and reduce the wastage of our operations. Another example is, and I think this is a common theme, I would say, is wherever operators use sensory perception to make decisions, AI and ML can be used to augment those decisions. And a lot of those models actually need to be run on edge in almost near real time and provide feedback to the operators. So I would say that that's a common theme where we are seeing edge use cases at this point.
How about you, Jai? Are you guys doing any ML?
So the way we are employing ML is, in terms of cleaning up our master data quite extensively right now. And, like what Amit was saying, from a governance point of view, you have those historical data points that were created, at the time of, let's say a system setup. And, that's causing us, a lot of problem because the business has changed. It's evolved quite significantly. For example, if you look at our safety stock numbers for each product, there are a lot of outages that we might have because there's a huge demand for alcohol and across the globe, irrespective of whether it was COVID or not. So, and we see that, some markets could be hogging some additional data in there, or, there might be just too much of a push on the plants to actually manufacture a lot more, but it's not really feasible. But if you start looking at the safety stock levels, or the lead times that is there, these have all been static for a long time. So what we're trying to do right now is trying to analyze the data that we have here and try to make them more dynamic in nature, in terms of pushing out to that back to those machines, and making it more agile, as you pointed out earlier. But also we're leveraging a lot of algorithms to help us determine what the right safety stock levels are, what the lead time should be, what the batch time should be, in terms of configuring the machines and the output that we're trying to get out of that. In that way, trying to keep the ecosystem in a much more flowing way.
Awesome. I love that. Evan, what about at FedEx?
At FedEx, we are not using a lot of ML at the edge, but it's still possible that we, as we develop more capabilities in our autonomous vehicle fleet, we are going to, process lots of image and video data at this, in the live stream, and then trying to avoid lots of safety concerns and to deliver our package on time. So that's still a possibility for us, but it's more, I guess, down the line.
Yeah, that is still so cool. And Attila, you must be seeing a lot of your customers using AI and ML.
Well, I am not too familiar with Intel customers. I know that we have really good product and great products for edge compute and edge devices. But where I would really add for manufacturing and productivity improvements, I agree with the visual inspection. However, our product is very small. So we have metrology tools, and out of the metrology tools, we have around 80% of our data is stored in images, as we taking this nano level images of the chips, and they are very repetitive work. Sometimes to recognize failure detection is very similar to using an image processing and image recognition, pattern recognition tools. That's one. I would really emphasize the preventive maintenance. This has been there for very, very long as an edge computer, an edge use case where you tap into some kind of data on the floor, either resonance, temperature, voltage, and kind of using that sensory data from the tools, you try to predict a failure, right? And I think that's really great because now you can avoid yield issues. You can do preventive maintenance. Sometimes you can expand your maintenance. Therefore, you reduce cost. But I would definitely say that as we're moving forward, 2023, we all know a lot of uncertainties out there. Cost cutting, cost reduction, productivity improvement of these edge devices will be very critical. I think there will be a lot of investment because it's very simple and easy to go. Now the challenge that the model, if you end up with more false positives, then you need more technicians to say no, that's not a problem. Yeah, thank you, yeah, yeah. So those are really the key challenges, especially if someone says, okay, let's go. Here's a factory. Let's deploy edge devices with a lot of sensory data, develop these models. Think about how many models you need to develop. It's just absolutely mind blowing how many data scientists you would need to to maintain and output those models for XYZ tool type of maintenance. Every tool needs different model, and it's not simple. So I think when there is a repetitive simple task, you have very key and not too dynamic environment, then edge devices will help you. But if you have an extremely dynamic environment, you have a zero error allowance on anything that you do. It's not as simple, and the challenges become really, really great.
Definitely. Back to the preventative maintenance you were talking about, a really cool example I heard about recently is on roller coasters. There are sensors along the roller coaster measuring vibrations per second.
Mm-hmm.
And if it goes outside of a certain range, they know that the roller coaster is going to need maintenance, so they can fix it before they have to shut it down, which is what they used to do. So I thought that was really cool.
Wow, that sounds amazing.
Isn't it? All right. So on that note, we hear and talk about the factory of the future often. So it tends to include goals like zero accidents, zero defects, zero breakdowns, or zero knowledge gaps. I want to know what your top one or two focus areas for improvement are when it comes to either data landscape, technologies, or processes. Jai, it sounds almost like you guys are focused a lot on zero knowledge gaps in terms of inventory. Would you agree?
Yeah, I mean, from an inventory point of view, there's a lot of gaps that we have, and as well as in terms of work in progress too, as well as inventory being stuck at different locations within our warehouses. So there's a lot of effort being put in to make sure that we are aligned in terms of what we really need is what we want to have at those different locations, because it does cost us quite a lot, especially in terms of the working capital costs, right? And the other one that's also causing us concern is, the transportation, because right now, I believe since COVID started, there's been a huge issues with transportation and hitting those numbers from an OTIF perspective, the customer on-time fulfillment rate. So we are trying to be as agile as possible and as collect as much information as possible so that we can try to hit those numbers, keeping those lead times in a more dynamic way, and so that we have those inventory available at the right time, at the right place, right? So I believe at my previous company, Racket, we did employ, a third party to look at, from a logistics perspective to understand, where our different products were in terms of, at different times, where was our inventory located, especially when it's in transit. It's a lot more difficult to predict where they are. So we used, weather-related data or, any other information that is coming up, from a transportation point of view. Let's say if there's a block somewhere, let's say the LA port has been blocked out, right? So it sort of uses all of that data points in there to simulate, what my lead time would be, and that way, it helps us to address, because there were pretty severe fines when you don't hit your OTIF numbers, and as part of that effort, we had to use a lot of edge data, and we did employ third parties, companies who specialize in this area to help us align with it, because especially with when it came to the COVID time, one of the products that we manufactured was Lysol, and we did have our production going on, 365 days a year, all three shifts, 24 hours a day, but we were still not able to meet our demand. And in spite of all that producing, if you're going to be stuck with transportation issues, then you need to see how you can optimize that so that you can reduce your load on the manufacturing side and ease that production out a little more. So it's sort of interrelated with each other, but definitely use of all types of data that came in over there.
Wow. So you think you have everything set in the factory, but you forgot about the weather outside. That can always
Exactly.
There's always
Yeah.
something, huh?
Yeah.
All right.
One other interesting thing that we also had, in terms of predicting the demand for airborne was, we used to. This is an interesting fact, right? If you look at the flu season in the U.S., how do we determine the demand for that? It's based on what happens in Australia. If the flu season is bad in Australia, they have like a leading indicator for you in terms of setting up your production lines over here, because that's the same impact US will have 6 months down the line. So it does help us in terms of looking at data across the board, things that you might have not thought about too.
Yeah, that's so cool. Attila, it sounds like you guys are pretty focused on zero defects in terms of like making sure all the chips are perfect. Yeah?
Absolutely. If you look at the factory of the future, if you walked one of our factories, you would be definitely surprised. How automated, how fancy looking and robotized everything is. So I don't believe that the factory of the future that really generates profit, because that's the only factory that exists. In terms of automation, I do believe that augmentation of factory workers, factory engineers working in factories, planning and designing, that's really critical. Now that augmentation is really hard. With current Amit mentioned, system integration, trying to get the factories different levels of systems integrated. I think that's what's really need to be definitely fully upgraded so that it's ready for analytics and it's ready to deploy very quick models. Current infrastructure just simply cannot do it. So I think we have to have a paradigm shift in the manufacturing control systems and the manufacturing planning systems, and that paradigm shift is yet to come. Many of our systems are extremely, maybe I should not say this, but it's outdated in terms of architecture because it's been really focused on relational database transactions coming in and collecting the transactions. That kind of view and that kind of architecture is not really ready for the factory of the future. So in my personal opinion, that's really definitely need to be a paradigm shift how we support systems. Now the other one, and just to mention, I think explainable AI is really critical for us. Factory of the future can explain why things happen, and don't think it's easy. Having for one of our chips, we can collect hundreds of thousands of data points, if not millions. Now, how do you figure out what really happened to the chip that it was defective? So, so for me, a factor of the future in the AI perspective, it is all explainable and can explain how to correct those actions.
I definitely agree with you. Looking at data management at a macro level, I'm definitely seeing that there's a need for infrastructure to keep up. And I think, companies definitely are trying to do so, especially I know we are at Dell. But there's definitely, it's going so fast, the industry, which is a good thing. How about you, Amit?
Yeah, I think the factory of the future, I think one area I would probably talk about is especially for heavy industries, the focus, I think where we are focusing is on safety side. Safety is one of the biggest priorities for Novelis because our environment by design is quite volatile, quite risky. So cutting down those accidents and incidents is quite crucial for us. So I think Evan touched about on this, but one of the areas where we are thinking about, again, marrying the question about edge deployment and factory of the future, one of the areas where we are kind of deploying or thinking about deploying AI, this is an effort that we are focusing on, is how do we avoid collisions inside the plant floor. So we have a lot of the vehicles, AGVs moving in the factory floor, and then we have cranes, and then there are forklifts, right? A lot of times we see accidents between these vehicles, and if we can basically put proper sensors and put proper intelligence on top of that, so that these vehicles communicate with each other at the factory floor, we can actually prevent some of these accidents. And that's one area I think we see a lot of value in.
Awesome. How about you, Evan?
I agree to you, Amit. I think FedEx can also benefit from having more sensors on our in our warehouses. But speaking of in the logistic industry, I can Jai, we are actually looking day and night into how to improve our customers. We are connecting our shippers to the recipient, and what we promise you want to achieve that promise, right? If there's a 3-day packages, want to get your package there in 3 days. So we're looking at lots of things that previously we're looking at, like packages by themselves. For example, how to if a package is traveling from New York to LA, how do we get the package there in 5 days? But as more and more companies are shifting from a static inventory management to a more dynamic inventory management, we are trying to adjust our system to also to how our shippers, our customers shipping their packages, right? So we're looking at a more network level operating improvement to take all the data in as we can, the package data, our labor data, our vehicle data, the flights data in, and then trying to look at our network as a whole to try to optimize the not only the network but optimize our customer satisfaction and experience.
Wow, that's a lot. All right, so
Amy, if there's time, I just like to add one other emerging trend that I've been reading about, quite extensively, and I think it's going to really take us out, is the digital twin. I think some of them would be familiar with that. I think we are starting to see more and more of that catching up. It might start with small processes, and then you're trying to simulate a same environment by mapping all of our manufacturing processes, what products we have, all the workstations that we have. Try to get all of that data and information, as you talk about the edge, right? Mimicking all of that in the digital twin. And I think one vendor explained it really well to us in a very easy to understandable format. If you look at our GPS is like a digital twin, when we're driving, right? So it tells us, different routes to take depending on what's going to happen in the future there, if there's a traffic jam and things like that. And I think that's something that's going to explode out in the factory of the future. Especially it might start with small processes because we may not have everything mapped out, but I think it'll evolve bit by bit, just like a Lego brick. It'll start falling in place to see that, as a whole for the entire factory down the line.
Absolutely. Okay, so we have 1 more minute, so I'm going to see if we can do this lightning round really quick. And Jai, you may have actually already answered yours. So we talked about challenges, which is always so easy to discuss, but talking about our inner optimism on what we're going to see in the future, in addition to digital twins. So if you all could just, in 1 sentence, tell me what you think the most impactful application of data science in manufacturing will be in the future. Sorry, Attila, go ahead.
Yeah, explainable AI and deep reinforcement learning.
Evan?
I think it's to build more automations in our warehouses and on the road.
Thank you. Amit?
I think in the short term, computer vision. In the long run, deep reinforcement learning. We are seeing a lot of value from that.
Awesome. And Jai, are you going to stick with digital twins?
I'll stick with digital twin, but I'm hoping that we have what you asked earlier about zero accidents and zero defects. If we can get to that in a more productive way, that will be the true ideal for the company too.
Absolutely. All right. Well, thank you guys so much for all of your insights. That was a great conversation, and thank you to the audience for attending. You can reach out with further questions to many of the panelists through the DSC team using the virtual expo area. So we'd love to hear from you guys. Thank you.
Thank you.
Thank you.
Thank you, Amy.
Thank you. Bye.
Bye.
Bye.